Okay, folks, this is Dr. Deviation, and this is the third video in the series, How to Analyze the Food Insecurity Data. And the statistics covered in this video are the Anova, which stands for the analysis of variance between two or more groups. In other words, the Anova statistic analyzes the average scores and the variation within those scores between 2, 3, or more groups, and tells you if the differences between them are likely just to be due by chance or perhaps are due to some other theoretical factors that are causing it. Now again, this video will cover the output of a simple analysis of the food insecurity data collected by the class. While this is a specific study, the examples discussed in these three videos apply to all aspects of descriptive, frequency, Anova, statistical, and correlation results data. There are also a good many videos on YouTube explaining these statistics and also how to compute them using either Excel or SPSS. This particular video is about understanding Anova, analysis of the variance between groups, statistical results. In other words, it's not about calculating it, but it's about understanding the results when you get them. Now, in this slide, I'm showing a typical output of an Anova statistic, which also includes the descriptive statistics, which I think helps to understand and interpret what's going on. So these arrows point to the aspects of the chart that I think are more important to focus on. So first, on the top, the two very dark blue arrows point to the two variables on the study. The independent variable, you might say, is gender. What is your sex? And the dependent variable is the food insecurity scale score. In other words, we're looking to see if gender influences what a person's food insecurity scale score would be. So if we look at the blue arrow on the left, we see we're comparing two groups, females and males. And the brown arrow showing the column of the mean scores, that means the average scores. For females, the average food insecurity scale score was 7.56, and for males it was 7.75. So here, females expressed more food insecurity than do males, although the scores are in the middle range. In other words, these are scales of above 7. They're not. Either group is not in danger just because of their gender. And the small blue arrow refers to the standard deviation, which gives you an idea of what the average amount of variation in scores are within each subsample. Now, the lower chart shows the Anova results. Okay, and what I need for you to focus on is the F score, which is the Anova F statistic, and that's a number. In this case, it's 0.340. And then the red arrow points to the significance level. That's the probability level. The higher the F score gets, the lower will be the significance score value. In this case, the significance score is 0.561. So in other words, that even though we find a difference between men and women in their hunger and security, this difference we found would happen 56% of the time. In other words, it's probably just due to sampling error of the particular sample of 138 people that we had here. So the difference is not statistically significant. For it to be statistically significant, that number on the SIG would have to be 0.05 or smaller. 0.0499, 0.049, 0.04, or 0.05. But anything higher than, say, 0.0501, that would be above the cutoff point that scientists use to say the results are likely to be just due to chance sampling errors and not to any kind of influences of one variable upon the other. This is a conservative interpretation, but this is the way we make fewer mistakes. Okay, now this is the difference on food insecurity scale by sex. So let's look at the next one, which is how many children live with you. So if we look at the blue arrow, that points to the number of children that's been reported, 0, 1, up to 5. The orange arrow is the average food insecurity score of those people. For example, 55 people in the sample said they did not live with children, and their food insecurity score was 8.25. Okay. And if you look, there's only 2 which show low numbers. The one living with 1 child, there's a 6.7, and also living with 4 children, there's a 6.5. But someone has 5 children and their score is 9, so they're not experiencing any food insecurity. Now let's look at the bottom chart, and here the F score now is 4.341. It's much higher, and the significance level is 0.001. That's much smaller than 0.5. So that's saying that the differences in these food insecurity scale scores by the number of children a person has, these differences would only occur by chance 1 out of 1,000 times if we did this study. So that's telling us that the number of children you have living with you does influence your food insecurity scale score. And in particular, there are other factors, of course. I mean, the person with 4 children has high food insecurity, but so does the 27 people who have 1 child. So it's not just the number of children alone, it's also other factors probably related to income or whatever that hopefully our other slides will show us. Now here we have the Anova between food insecurity and if you are a student. Now there were 3 answers to that question. No, you are not a student. Yes, a part-time student, and yes, a full-time student. And if we look at the mean scores on the food insecurity scale, we see it's lowest for the part-time students. So the non-students, either maybe they worked, and the full-time students had other means of support. So it's maybe the part-time student that had to work as well as go to school. Their food insecurity scale scores were lower. And again, if we look at the bottom, the F score is 3.2 and the significance level is 0.04, which is smaller than 0.05. So there's only a 4% chance in 100 that these differences in food security scores could have happened by chance. So obviously, being a student and what kind of work you do influences your score. Okay, now, what is the gender of the head of the household, the head adult in the household, and their food insecurity? Okay, so if the gender was male, their food insecurity score was 7.89, but if it was female, their average score was 7.25. And again, if we look, the F score is 4.08, and the probability of that F being due to chance alone is 0.045, which means it's only 4.5% out of 100. So it is below the 5% level of significance, so we would reject the null hypothesis that is due to chance and say that female head of households do experience more food insecurity than do male head of households. Now, in this slide, we're looking at, do you receive electronic benefit transfers? In other words, does the person receive food stamps? And what is their food insecurity scale score? So if we look, we see that people who do not receive food stamps, that's the 0, their average food insecurity score was 7.43. While those who were receiving food stamps, their average score is lower, 7.45, indicating food insecurity. And if we look at the F score, again, it's 4.5, and the significant is 0.34. So the likelihood that this difference could have happened just by chance is less than 3.4% out of 100 times we did this study. So people receiving food stamps do experience more food insecurity. In other words, they should be receiving food stamps. Now on this chart we're looking at do they receive Medicaid, and what is their food insecurity scale? And it's poorer people who receive Medicaid. So those not receiving Medicaid, their average food insecurity scale score is 7.49, and those receiving Medicaid, it's 6.29. And if we look, this F score on that is 7.27, and the significance is 0.008. In other words, that's less than, if this study was done 1,000 times, and only 8 of those times would we find differences in food insecurity this great or even greater if there was truly no difference between people who received Medicaid or did not and food insecurity. So that people on Medicaid tend to be more insecure about food. Now finally, the last slide in this video is the food insecurity scale with do you visit food pantries where you can get food for free. And if we look in the blue, no, that's 114 people, their average score was 7.8. Those who said yes, there were 24 people. Their average score was 6.79, lower, meaning more food insecurity. And the F score is 6, and the significance level is 0.015, which is 1.5%. Remember, anything less than 5% we would consider not being due to chance. So people who go to food pantries need to, because they experience more food insecurity, and this is how you would interpret an ANOVA that you would run on your statistical data. With the data the class collected, it'd be possible to do different analyses than the examples I've given here. But the purpose in these videos was just for you to interpret what it is the findings show. And with that, that's all for now. I want to again thank you for listening and watching the video.